Okay. Awak semua sibuk tak? Ke awak bahagia? Awak bahagia ke tak bahagia? Kenapa lambat Aina? You are late for 3 minutes.
Wi-Fi better.
Apa?
Wi-Fi.
Wi-Fi? Okey lah, dimaafkan. Okay, so bahagia ke tak bahagia ni Najwa, mana orang lain yang tak buka kamera ni? You want me to kick you out or yang tak buka kamera tu tak beritahu kenapa? Kan ada beritahu saya macam tak ada. Dengar ke tak dengar ni Hambali dan Solihin.
Hambali dah buka madam.
Ada PC ada PC dengan full.
Oh, awak Hambali ada kat situ. Pening dah saya. Okey.
Saya tak kat kamera. Saya buka je.
Awak baru buka, tadi awak tak buka.
Oh tak, tadi sebab saya visit Google Form.
Macam-macam masalah. Okay. Alright. So, okay, let's go continue. What do you want to ask me before I start asking you? It's always a game with me. Kalau student tak tanya soalan, get ready. Saya akan tanya awak soalan bertubi-tubi. So you better tanya saya soalan so that awak tak kena tembak lah soalan daripada saya. Macam tu juga research ke, you kena tanya saya soalan dulu. Kalau saya start tanya soalan, dia baru tahu, banyaknya tak tahu. So you better ask first. Okay, silakan. The floor is open. What do you want to ask me?
Lattice constant, madam.
Lattice constant. Okay. Silakan tanya dengan ayat yang penuh.
Penuh. Madam, what's mean by lattice constant?
What do you mean by lattice constant? Okay, have you Google, okay, I give you 30 seconds. Google lattice constant and tell me and ask me a more specific question. Okay, everybody Google 30 seconds lattice constant. What is it? It's a good question. Yes, you need to know what is lattice constant.
Physical dimension of unit cell in a crystal lattice.
What is it? In your own words.
It's parameter or...
Boleh cakap kuat tak sikit Azam? Saya ni dah buat
Tak dengar.
Saya punya ni tak berapa, suara macam jauh-jauh je. Suara saya clear kan?
Clear.
So kenapa? So I want your voice as clear as my voice. Okay.
Madam.
One thing about communication skill, setengah orang memang ada suara orang kuat, ada setengah orang tu suara dia kuat. Ada suara setengah, kenapa Hambali terbalik pula punya kamera tu? Macam-macam. Okay, so ada setengah orang tu suara dia tu perlahan. Tapi kalau kita dalam if you want to have good communication skill, we want the people that hear us can hear it clearly. So we need to improve on the way we talk so that kalau suara kita perlahan pun tapi at least jelas. So dia bila tak kuat ni kita tak jelas, orang tak faham. Kalau kita jadi boss pun orang tak faham apa benda dia nak ni. Macam tu. Okay, so Azam.
Hello, madam. Dengar tak?
Dengar macam tu juga.
Slow kan?
Jerit sikit boleh tak?
Oh,
tak boleh jerit.
Jerit.
Shout.
Lattice constant ni dia macam parameter untuk apa? Atom tu. Macam case lah. Tak tak madam? Macam casing.
Casing?
Ke bukan?
Casing?
Ibaratnya ibaratnya macam casing untuk atom. Is it?
Tak.
No?
No. No. Anybody else wants to what you call it? To try?
It is a parameter that determines one thing.
Huh?
For example, it is a
Parameter that what?
parameter of a physical dimension. For example, kalau for the chemistry, there is something macam even is it speed of light is considered as a parameter? It's a constant parameter kan?
Awak faham ke tak sebenarnya? Dia simple je sebenarnya. Ayat dia bombastic. Okay, can you see my iPad ni? Nampak?
Nampak.
Nampak.
Do you know what I'm drawing? Can you guess?
Electron? No.
Atom.
Good guess. Okay, no. Punyalah tak cantik. So this is a lattice. You know what is a lattice?
Arrangement of atoms.
So lattice is arrangement of atoms in a regular manner. So for example, you have, so each one here is an atom. Ni semua ni atom. So lattice is combination of atom. So remember last time we talk about a piece of semiconductor here. Mana? Here, a piece of semiconductor here. So it has a lot of atoms inside, and if it's a pure semiconductor, you will have lattice. Okay, lattice is just arrangements of individual atom. So it will be like an array. Dia akan macam regular. Okay, so this is a lattice. Ni 2D lah. I'm drawing it 2D. Okay, now. So what is a lattice constant? Lattice constant is the distance between each atom. Biasanya dia simbol dia A. And unit dia Armstrong. Apa benda Armstrong ni? Anybody knows?
I guess.
So Armstrong is 1 times to 10 power minus 10 meter. So kalau 10 kuasa negatif 9 meter dipanggil apa? 10 kuasa negatif kalau 10 kuasa negatif 9 kita panggil apa? Nano. Armstrong ni dia memang spesifik, dia 10 kuasa negatif 10 tapi memang unit dia dah meter. Kalau 10 kuasa nano ni dia tak ada meter, it can be nano number of biasa kita kata nanometer kan. Tapi Armstrong ni is already included in it is the meter. So let's say they say the A lattice constant equals to 2.3 times that dia kata 2.3 Armstrong. So it means that it's 2.3 times 10 to the power minus 10 meter. Okay. Lagi soalan? Faham? Kalau tak faham tanya. Sebab banyak juga soalan ni akan keluar kat exam nanti. Semua basic-basic ni. Kalau tak tanya soalan, saya tak tanya awak soalan, benda tu ada dalam slide, saya assume awak faham. So jangan terkejut keluar dalam exam. Okay, lagi? Because I already given you the chance to ask me.
Next. Mechanical stress ada dalam
Tak dengar lah.
slide, madam. Mechanical stress.
Mechanical stress. Apa benda mechanical stress?
Saya ada jumpa dalam slide. Sekejap, saya tengok balik.
don't understand. Can you
Okay,
ask the
madam.
question in a full and what do you mean? Which part is the, because I don't know which, what's the scenario you're asking?
Are you talking about the one inside the interesting facts?
Yeah, interesting facts.
So it says here gallium arsenide and aluminum arsenide has almost the same lattice constant. We can thus combine any combinations of these materials without encountering mechanical stress.
Okay, that's an interesting question as well. Mm,
Combine with mechanical stress. Are we talking about doping?
see my
Stress.
2 point.
Like 15.
Slide nombor apa?
15. 15.
Eh,
Ha.
mana mechanical stress? Mechanical stress ni lah. Okay. Dia ada kaitan dengan lattice constant tadi. So it has a relationship with the lattice constant. I will share my screen again. After this, orang lain tanya soalan. Maksimum 2 soalan tu kita rotate. Siapa yang tak ada tanya soalan, maknanya dia faham semua benda. Dan kita boleh buat quiz terus lah. If you understand everything, right? No need for me to teach. Very easier for me. Okay. So now we say mechanical stress. So they say, okay, now let's say this so this is a lattice. This is a lattice, right? So lattice of, for example, let's call this lattice of silicon. Okay, lattice of silicon. And it means that the lattice constant for silicon is different than lattice constant for gallium arsenide, germanium. The way the atoms arrange itself is different from one material to another material. Okay, so the lattice constant will be different. So the distance between an atom to another atom in the material will be different. Okay, in order to answer your question, there are 2 types of semiconductor. Dia banyak kategori lah, ni kategori lain sebab yang atas ni on the top we talk about different type of semiconductor material, intrinsic, extrinsic, but we also we have within the intrinsic we have apa nama ni, elemental or compound. That's the word, elemental. Remember last time I forgot the word. Mana kat mana saya tulis?
Bawah sikit.
Here nak elemental. Elemental means one element, which is silicon, germanium. That's a type of what do you call it, semiconductor, intrinsic semiconductor. But you can also have compound semiconductor, which is consists of different elements, which is gallium arsenide. It becomes gallium, the atoms of gallium and the atom of arsenic. Put together, it becomes a semiconductor material. If alone, it doesn't become a semiconductor material. It has to be compound in order for it to become a semiconductor material. So, and gallium arsenide and silicon carbide. Okay, now semiconductor also. Saya nak sebut apa tadi? Kenapa saya bagi 2 tadi? What we talking about before?
We're talking about
Type,
mechanical stress.
kategori madam.
Sebelum tu, kategori, sebab dia banyak kategori. Apa saya cerita?
Mechanical stress.
Mechanical stress.
Oh, okay. Ni. Okay. Semiconductor device. Okay, tadi yang atas ni, kategori on the top is the semiconductor material. Intrinsic semiconductor material. Even this is semiconductor material. Now, semiconductor device is a device that made out of semiconductor material. Okay, when we say semiconductor device, it's just, when we say device, we can use it. There must be current. We can use it for certain application. We say device. Material, maybe it's just a material. We don't know what's the application. Maybe there's no application yet. When we say semiconductor device, which is our course here, it means that we use semiconductor material to come up to make a device. So it can be used in a certain application. So we have 2 types. If you want to make a device, we have structure or hetero structure. Okay. Structure, it means structure of the device. Structure is how do we use a semiconductor material to make the device. So homostructure just means that we are using one type of semiconductor material for the device. So macam ketul. If it's a silicon, the whole thing will be silicon. Or if it's gallium arsenide, the whole thing is from the material of gallium arsenide. Heterostructure means we combine different semiconductor material in one device. Okay, heterostructure means we combine different semiconductor material in one device. Okay, so jadi macam ni lah. So for example, we want to make silicon germanium diode. So we have silicon, and then we combine it with germanium. So ni silicon germanium. Okay, so silicon is one type of semiconductor, germanium is another type of semiconductor. We can put it together. Okay, for example, another example is okay, gallium arsenide and we combine it with indium gallium arsenide. So indium gallium arsenide is a semiconductor material. It's a compound semiconductor where we have three elements: indium, gallium, and arsenic. Gallium arsenide is a compound semiconductor as well because it consists of gallium and arsenide, arsenic. So these two. So these are homostructure. This is heterostructure. Now the question is, can we combine any semiconductor? So okay, so can we combine any semiconductor? Let's look at our periodic table. Okay, this is our periodic table that we looked. Let me padam sini. Okay, so then okay, so if you look here, okay, for example, just now we combine silicon and germanium, right, to make a heterostructure. Can we combine gallium arsenide, which is one semiconductor, with silicon? Or can we combine germanium with indium arsenide? Indium arsenide also a type of semiconductor material. Or can we combine gallium arsenide with indium arsenide? How do you know? So the answer is it's not as simple as that. We cannot just pick one semiconductor material, put and then put it together, it will work. It will not work. Why? Because there's this, what they call it, the mechanical stress. Okay, so let's go back to our drawing. Okay. Now let's go back to this drawing here. Okay, this is a lattice, right? So so let's draw two lattice of two different semiconductor material side by side. So kita draw kat sini lah, besar sikit. So now let's draw the, for example, silicon tak boleh. Kita bukan side by side, top bottom. Kalau side by side tak nampak, okay. Okay, so this is for silicon. And then let's draw another one material. Let's for example gallium arsenide, another semiconductor material. But this is just for example, right? I didn't check what's the lattice constant for silicon and gallium arsenide. You can check later. This is just an example to show the difference in the lattice constant. For example, this one. For example, let's assume gallium arsenide has a, or maybe to be safe, let's call not name. We call A and B. This is semiconductor A, semiconductor B. Semiconductor A, let's say the lattice constant is 1 angstrom. And semiconductor B, let's say the lattice constant is 2 angstrom. Okay, so it's a, what do you call it, double. Okay, so semiconductor B has a double of the lattice constant of A, of semiconductor A. So we should draw it, so it's double kan. So kita kena macam ni. Okay. Now, so when you have lattice, when you have atoms in a, so we're going back to SPM, the atoms in the semiconductor, these atoms in the semiconductor, is it apa nama ni, bond to each other? Is it bonded to each other ni, all these atoms? Is it a
Yes.
bonded bond?
Yes.
What kind of
Yes.
bond?
Covalent bond.
Okay, thank you. It's covalently bond between each other. So there's a bond. So they terikat. Okay, there's a bond. Similarly, semiconductor B will also have the bond among themselves. Okay, that's why it's a piece. That's why if you can have a piece of semiconductor because there's bond. Kalau tidak kata lerai ya semua. Now we want to make a device that combines these two semiconductor into one, right, device. So what we are actually doing, we need to bond semiconductor A to semiconductor B. So let's draw first the bond in A lah. Kita kali jauh. So this is how it bonds with each other. Okay, so nice bond. It's not stretch. But okay, so but this is the bond of between semiconductor B. So they also have a bond among themselves. So no problem. Now the problem is when we want to bond these two. So how when we put it together, it will need to bond. So what happens is this one will bond with this one. This we need to bond to this one. This bond with this one. Imagine that one will go further, right? What happened is it's like this bond. You can imagine bonds are like getah, elastic band. Elastic band. Tak ada getah kat sini lah. Ambil je lah apa-apa. So this is elastic band. It's stretchable. But you can only stretch it to certain limit. Okay, it's stretched. So but kalau getah elastic band, you keep on stretching, what happened to the elastic band?
Might putus.
Yes, it will be broken, or it will be snap. It will snap or broken. Okay, similarly, so similar to this bond here, so you can see that this is no problem. But as you go, and you have to imagine this I'm only draw 1, 2, 3, 4. We have how many in 1 millimeter by 1 millimeter by 1 millimeter? How many atoms? Remember?
10 by 30.
Yes, 10 to the power of 30. Mana satu dah? 10 to the power of 30 here, atom. A lot. So can you imagine what the bond will be? Later. No, there will be some some atom that will be broken. The bond will be broken. Okay, and this, when you stretch this, we call it mechanical stress. Okay, sometimes it can be sometimes we call it stress. It can be stress or strain. And you go Google what's the difference between stress and strain. So it means that when we put two semiconductor material which are not similar, it doesn't have to be equal, but similar in lattice constant, it will be you will not be able. There will be a lot of broken bonds. When the bonds are broken, then we have defect. Okay, so what is defect? Let me ask you. Anybody knows what is a defect?
Kecacatan.
Can you say it louder?
Kecacatan, madam.
Kecacatan. Okay. All right. In Malay, in exam, you cannot answer that. So, what do you think defect in a semiconductor means?
It loses its property, basically.
What, Faiz?
Yeah, the semiconductor material loses its property. Like it can no longer act as a semiconductor.
Wow. So it act like apa? It become a conductor, insulator. What it becomes?
Which actually depends on how the defect affects the materials, I guess. So hold on, are we talking the defect after they combine or?
No, it's just we are talking about defects in semiconductor material.
Okay, that's just a guess of mine. So
So what is a defect in semiconductor material? What is it? So what does
Abnormal.
it do? Have you seen a defect in semiconductor before?
No.
Anybody? Okay, now Google, 30 seconds. Google defect in semiconductor. See, get some images. See what kind of image. I will call you, you share your screen. See, do you get the right image or no? Menyesal masuk kelas ni. Sebabnya banyak kena interact. Macam tu saya dah beritahu kan. You need to interact. You can still drop if you want to drop. Okay, 30 seconds saya tak check masa. Faiz, you always be my timekeeper. Kalau saya kata 30 second anytime dalam kelas ni, awak kena check. Okay.
on it.
Instead of you searching, you kena jaga masa juga. Dah tinggal 20 saat ke 10 saat lagi.
Take 15.
Find the best image that depicts the semiconductor defect, then you show, then I will tell you whether it's right or not. Finish? Okay. Siapa yang senyap ni? Hambali. Can you share your screen? What do you get for image for semiconductor defect? I want to see this image.
Yes.
I told you, right? Find image. Mana? Hambali. Mana image awak ni? Tak jumpa ke? Daripada tadi awak cari apa awak jumpa?
Tadi lagi dia punya tu.
Apa benda?
Dia
Saya
punya
image
definition.
Saya tak minta saya
Definition
definition. I ask you to find the image. Dah, pilih satu cepat. Pilih satu. Apa tu?
Tak ada.
Baru nak cari ke? Okay, let's orang lain dululah. You get ready. Get ready, find one. Aiman, show me your semiconductor defect image.
Nampak ke macam?
Oh, baru nak nampak. Okay. Alright, nice. You understand?
Has holes.
And then vacancy. Okay, vacancy. So, okay. Alright. So everybody look at this photo here. There are many types of defects in a semiconductor. Many types of defects. So this one type of defect, the name of the defect is called vacancy. You nampak dia tulis kat sebelah kiri yang sengit tu kan. Anion vacancies on p-doped surfaces. So defects can manifest itself. You can see some of the defects you can see using a microscope. So there are, kalau so you can see, nampak tak yang macam bulat-bulat yang putih tu kan? The white circle there, the white circles there, it's actually atoms. So there are many atoms. Okay, you can see. So you see many atoms. Suddenly there's a black. Black is the defect. Okay, and this vacancy is a type of defect whereby we are losing one atom. So you can see, awak tak nampak kan saya punya ni cursor ni, tapi satu, cuba tunjuk ke awak, 1, 2, 3, 1 ke 3 ke bawah, and then 2 ke tepi. That one. So this one, you can see all the atoms there, and you can see one missing atom, yang hitam tu. So when one atom missing in a lattice, this whole thing is a lattice. When you can see many white circle there, is each one is an atom. So it's actually the nucleus that you see here, and then the black there is the missing atom. So when a missing atom happens, it becomes a defect. Okay, thank you. Stop sharing. Ada soalan on defects? So because you are seeing atoms, right? Atoms, you know the distance between atom to atom is very small. 10 to the minus 10 meter. It's actually very extremely small. Nano already small. This is more roughly in the range of nano or tens of nanos. So or less half of nano. So jadi dia punya in order to see the defect using microscope, you cannot use the normal microscope that you use in your high school, the cheap one. Cannot. Okay, we need to use the expensive, like 200,000, 500,000 ringgit one microscope. You can use it. You can see it using scanning electron microscope. In IIM we have, tapi tak tahu rosak ke tak. Kalau rosak tu baiki dia punya mahal, right? So there are different types of microscope as well. Macam-macam. Kalau belajar lagi, buat master ke PhD ke, you will know that there are many type of other microscope. So you can see this defect. Some of the defects it manifests in the physical, which yang microscope ni physical, you can see with your own eyes. So what we are concerned, if let's say katalah this piece of semiconductor, you look in the microscope, it's very ugly. Semiconductor pun ugly, ya kesian lah. Dalam manusia pun ugly. Semiconductor pun boleh ugly when you have a lot of defects. So penuh defects je, jerawat kat situ, macam-macam penuh. So it's an ugly when you look in the microscope, it's ugly. But when you use it, okay, you put current through it, there's no difference between an ugly semiconductor and non-ugly semiconductor. It means that the defect is not electrically active. So what I'm trying to say is defect ni, dia ada, saya terus sikit lagi. Sebab kadang defect katalah, saya nak bagi analogi kan, kalau muka tu, katalah muka tu macam tak sesuai lah pula macam I'm trying to give an example, right? Although it looks bad, kita nampak orang tu tak cantik tapi hati dia cantik. Macam itulah nak ceritanya. You know, some people dia nampak gemuk, jerawat penuh, apa ni, mana-mana nampak macam, you know, bagi orang macam tak best lah. Tapi sebenarnya hati dia cantik, yang itu lebih penting. So for us pun, in semiconductor device, the same. Sometimes it looks ugly, tapi it's electrically, hati dia kita dalam semiconductor ni is the electrical performance. Tak ada masalah. So we don't care whether dia penuh dengan defect ke tak. Okay. So let me share my iPad. Dalam Islam pun Nabi kata innallaha la yanzuru ila, siapa tahu hadis tu? Innallaha la yanzuru ila student UIA 4th year ataupun dah grad UIA. Can you complete my hadis? Innallaha la yanzuru ila. Do you understand what the hadis says? Bahasa Arab tu. Innallaha la yanzuru. Aiman?
Oh, madam.
Awak tahu bahasa Arab tak, Aiman? Tak. Bukan awak ambil bahasa Arab ke kat UIA?
Tapi dah lupa macam.
Oh, kenapa lupa? Tak penting ke?
Penting, tapi itulah tak guna. Masa tu je lah guna.
Kenapa tak guna? Sebab tak penting ke? Tak tahu nak guna kat mana? Oh, kita baca Quran tak? Awak baca Quran tak?
Baca.
Baca. So bahasa baca Quran kan bahasa Arab. Tak pakai kat situ.
Sebab belajar basic macam tak faham lagi sangat.
Tu lah. Awak tak rasa ke awak patut belajar bahasa Arab?
Patutnya.
Bukan yang dapat gaji tinggi pun, tak menambahkan gaji pun belajar bahasa Arab ni. Ke macam mana, Aiman?
Kena belajar.
Tapi kena belajar, tapi kita belajar bila kita tua lah kot. Bila pencen dekat nak mati tu kita belajar tak. Sebab masa tu kita dah tak sibuk. Ke macam mana? Betul?
Sounds like a plan.
Yeah,
nothing. Sorry.
Apa, Aiman?
Sekarang pun boleh belajar juga.
Tapi macam ada tetapi.
Tak ada.
Are you sure? Okay, brothers and sisters, you know what IIUM is giving you actually very, they're giving you a seed. So when they teach you bahasa Arab, they're giving you a seed. You're supposed to grow the seed. But then you kill the seed. You yourself kill the seed, although we planted the seed inside you. So every one of you have a seed inside you already. It depends on us whether you want to grow it or no. Arabic language is extremely important for us to understand Islam, to understand the Quran. So you are very lucky. You are all learning in IIUM. Saya belajar kat UK, mana ada orang nak ajar saya bahasa Arab, right? But and I don't have this Islamic worldview ke apa. I have to find it on my own. You are already given on a plate everything. It depends whether you want to remember it, use it or no. So it's very sad when people given it to us tapi kita tak pakai kan. And I just want to tell you when I masuk UIA, I remember kerja lah. Saya tak belajar kat UIA, saya semua UK. Bila saya start kerja kat UIA, the first thing I do when I started working in IIUM was to find an Arabic class at night. Saya pergi kelas, masa tu saya dah kerja, saya berbayar kan. Tapi you student, there are a lot more free classes in IIUM. Student buat kelab lah macam-macam. I saw iklan yang rata-rata. Tapi tak ada orang pergi pun. I don't know why. So I paid for the night classes. Siang hari mengajar jadi lecturer, malam masa tu saya tak kahwin lagi lah. So saya ada banyak masa. So malam I will go to this Arabic classes. Why? Because in order for us to understand the Quran, we need to have we need to learn, we need to understand Arabic. Kalau tak macam awak baca Quran, awak faham tak baca Quran tu apa? Nanti kita buat test lah. Awak faham tak Quran yang awak baca tu? So how come kita kata kita follow Quran dan Sunnah when we don't even understand what Quran says? How is it possible? Okay, is not learning to understand the Quran is what you call it as important or more important than the engineering subjects? Less important. So Islam is less important than engineering. So, you know, when you put things in perspective lah, I'm just telling you so you should think. Kat mana letak priority dalam benda dalam hidup ni. I know you are very busy, but also you will susun your busyness depending on your priority in life. Okay, if your priority to get an A in semiconductor device, you will put all out, right? But if you think priority to learn Arabic is in your life, you do everything in order to go and learn Arabic so that you can understand Quran. So the Prophet says, hadis kata, Inna Allah, inna, who knows what inna means? Ambil dah masa saya macam ni, tak apalah. Inna, sesungguhnya,
Oh, certainly.
Allah, inna Allah, verily Allah, la yanzuru, la,
Melihat. Tidak.
la, doesn't, bahasa Inggeris lah, Faiz selalu cakap bahasa Inggeris tu, Melayu pula dah. La yanzuru.
Doesn't look.
Look.
Doesn't look. La yanzuru ila
Words.
towards suwarikum. Suwar,
The face.
inna Allah la yanzuru ila suwarikum wala wa
And
la
not.
wala ila ajsadikum, jasad,
Jasad. Body.
plural of jasad lah, ajsadikum, jasad kamu, walakin
However.
walakin yanzuru,
Look.
he looks, ila,
Words.
towards qulubikum, qulub,
Heart.
your hearts, wa a'malikum, a'mal,
Sorry.
Practice.
and your practices, your amal. Okay, so it's hadis sahih. So basically Rasulullah SAW said Allah doesn't look at your face. You have a lot of pimples, jerawat, gemuk, kurus, sado tak sado. No, it's not even important to Allah because Allah gives you that. Inna Allah la yanzuru ila suwarikum wala ila ajsadikum, and not even to your physical body yang kita duk sibuk sangat jaga makan tu lah, makan ni lah, nak suruh tu. Allah tak care pun. Walakin, but what's important to Allah is walakin yanzuru, Allah looks at your hearts, what inside you. So walaupun seburuk mana kita orang kata kita buruk, sebenarnya tak ada pun Allah create anybody yang buruk. Kita je rasa kita buruk, which is wrong. Tapi Allah tengok in our hearts. Muka cantik, badan sado, hati berkulat, hati busuk. So tu yang Allah tengok. And then wala ila qulubikum wa a'malikum, and whatever you do. And that's what Allah looks at. So that's very important if you understand this hadith in our life. So we will, what is priority? Because nowadays people looks at luaran . Dia ni pakai baju apa, branded tak branded, dia ni orang kaya ke miskin. Who cares? What is the most important? The important of what people think of you or what Allah thinks of you? Right? Which one is more important? Malu lah madam. Who cares? Malu apa? Kalau Allah kata kita bagus, siapa nak kata kita tak bagus? Right? So, tapi masalahnya semua orang nak luaran. Media-media pun nak luaran. Tu dah hancurlah manusia sekarang ni. So, going back to this, the same defect can be defect can be apa nama ni? We have physical, you can see it, physical defect, like physically active defect, electrically active defect, and we can also categorize as optically active defect. It means that what I'm trying to say, although you physically active means it's physical, you can see it, but it sometimes it can be physical, but it's not electrically active. It doesn't affect the electrical performance of the device. And then sometimes, but it can be most of the time, if it's physical, it will affect the electrical, and it will affect the optical. Biasanya macam tu. That's general rule. But there are there are also what they call it some few very rare circumstances that physically you can see it, but it's actually not affecting the electrical or optical. There are certain defects like that. Okay, so our job as semiconductor device, we are interested in these two. Okay, so later, because we will be learning about optoelectronic device as well, so we'll be learning about these two. So defects also have many types, banyak jenis. So the one that you see just now is a vacancy. Okay, you can also have dislocation. This vacancy is just one, you missing one atom. Kalau macam ni ya, dia macam dia ada gini. Tiba, sepatutnya macam ni kan. Saya draw cepat ni. One atom missing, this is called vacancy. Okay, you cannot see it, but in the microscope you see it as a dark. Okay, so it's a vacancy. But let's say this location ni dia macam ni. This location dihilang in a row. If you lost like this in a row of an atom, it become a dislocation. So you can Google after this, how does this location defect looks like. Dia nampak macam ada line. Okay, so kenapa kita cerita pasal defect ni? 10 minit lagi. Because
mechanical stress.
Yes, because mechanical stress or strain ni, it will break the bond and will create defect inside the structure, and we don't want defects. Therefore, when we have these two types of material together, we want to choose semiconductor material which is closer to in terms of the lattice constant. Okay, so that's why ada ke graph tu kat sini. Okay, that's why this graph is very important. This graph very important. This graph always come out in my final exam every year. Tapi biasa student tak tahulah, ada yang sudah dapat A tu boleh jawab lah, yang tak dapat A tu dia tak jawab. Saya tak faham pun.
Okay,
Masalahnya tak tanya pun saya kalau tak faham. So this is
Madam,
graph.
do you mean that we will avoid defects even though sometimes defects will make the semiconductor work just fine except for electrical active defects?
Yes, we try as much as possible to avoid any defect, because awak katakan defect suka cacatan, siapa nak cacat? You know?
Even though it can work just fine. Even though
if it can work just anything in pure, there's no defect. And you need to understand, maknanya anything perfect has no defect. Anything perfect has no defect. So we aim always for perfection. So, but if there's defect, we need to categorize it. If it's not electrically or optically active, we just ignore lah. It's okay to have the defect. But the defect comes due to certain. How do you get defect? Number one, missing of atom. Number two, how do you get the missing of atom? The missing of atom, you can get it through to another syarahan, which is it's not covered in this course. You can get the defect through many things. For example, when you heat the semiconductor in the furnace to make the layer of the the epitaxial layer, yang tu nanti kita akan cover later. When you make the device tu, structure tu, the temperature is too high. For example, it's like an oven. Bila oven tu tinggi sangat, pressure tak betul pun boleh dapat defect. Kedua, defect, you can have defect by impurities coming pun you can get defect. Any tiba-tiba termasuk something benda ni, you get defect. Biasa macam itulah. So maknanya if you get everything right, the temperature right, the pressure right, there's no impurity, everything, dia akan jadi perfect, nearly perfect. You know the silicon that used for MOSFET nowadays, for the IC chip, you know how pure and free of defect it is. Sebab nothing is perfect in this world. Only Allah is perfect. Kalau kita nak buat apa, we'll never get perfection. But we are striving for perfection. So semiconductor, for example, MOSFET IC, they use a silicon of a purity of silicon tu 99.9999999%. So dia ada 0.001% yang ada impurities. It tries to get rid as much as possible. Why? Because defect ni bahaya. Sometimes defect we cannot we cannot predict how it will react in certain condition. Okay, sebab tu kita tak nak defect sebenarnya. Sebab tiba hak ni okey, kita rasa optically ni tiba kita tukar pakai dekat desert kan, macam ada war ke kat desert tiba tak boleh pakai sebab defect tu tiba behave differently. Sedangkan kita punya teori kata lain. So defect ni sebab tu there are a lot of research studying the defect pula. Macam mana defect ni, how the characteristic of defect. Dalam keadaan macam ni apa jadi? Keadaan macam ni macam jadi. Okay, also you can get defect if you use the device in a harsh environment. For example, in a nuclear radiation environment, if you put the semiconductor material, silicon carbide ke, and silicon ke in this material, it will damage the material. So you will get defect. Or you use it in space. Space ada banyak radiation juga. So when you got this radiation hits the semiconductor, it will also create defects. So that's why there will be a lot of study on defect and its effect. So we try as much as possible to avoid defect.
Thanks.
Okay.
Understand, madam.
Alright, so let's go. Kita ada 4 minit lagi. Yes.
Madam, defect is a vacancy of atom kan?
It's one type. There is only one type.
And that,
Bukan is. This is just one type of defect. You understand?
how to differentiate between vacancy and the whole?
Oh no, this is a vacancy of atom, bukan a vacancy of electron.
Oh,
Atom dan elektron lain kan? Kalau sama kita kena masuk darjah 1 balik lah. Kalau kita kata atom.
Even see the electron inside the image before. You cannot even see the electron inside the image that shown before.
Yeah, you can. Nobody in the whole wide world until now, I'm telling you, nobody in the whole wide world doing PhD ke Nobel ke prize ke, nobody has seen an electron. Why? Because electron cannot be seen. Why? Because of the quantum mechanics. Dia banyaklah teori untuk explain. Sebab electron ni, we assume it's a particle, but actually it can also is a wave. Particle duality, the quantum mechanics. So therefore, bila dia wave ni, how do you see a wave? Dia can keep on moving. So and interestingly, they keep on moving, and our camera cannot capture it. So because the speed of its moving is the same speed as we are capturing. So benda tu tak sempat nak tangkap. So never ever let people see an electron. How do we know electrons there? Is by measurement. Kita buat measurement, ada mass pula, kita calculate, oh dia ada mass. Kita calculate, oh dia behavior dia macam ni, speed dia macam ni. Tapi nobody actually have seen an electron. Atom, yes. Atom, dalam atom tu ada elektron, ada nukleus. Nukleus ada proton. Proton ni macam mana kita nak tahu proton dengan neutron tu ada? Dia ada eksperimen dia pula. Kita ketuk dia keluar. tu nantilah tu payah kalau cerita-cerita ni tak habis kita punya semiconductor device macam ni. Ni baru sikit ni. Kita tak masuk lagi device. Okay. So vacancy of an atom, not vacancy of electron. Jangan tertukar. Terima kasih tanya sebab kadang-kadang saya assume awak clear. Okay, so now you go back, go and learn this. Ask me any question on this. Okay. So kita tak habis lagi slide ni. I want you to go and read more. Ask me more question, especially this one. I want you to tell me what you understand about this. Sekarang ni you know understand dah lattice constant tu apa. Band gap pun patutnya udah faham. So what this telling you? Okay. Dan semua soalan lain lah. Kalau tak tanya saya, I assume you know. Saya dalam exam, awak jangan terkejut. Okay, that's how we going to do it. Alright, 1 more minute. Any question?
Madam, about the picture, we have to learn just the picture. Is there any penerangan on that?
The penerangan, cari sendiri penerangan. You have a textbook, right?
Okay, madam.
Go and find it. You have internet in the whole wide world to help you. Go and find it. So
Alright, madam.
macam tu kita bukan millennial belajar macam tu ke? Kita tak payah ajar kan. Awak semua pandai kan search. So ada buku berlambak buku. Buku yang dalam kos online tu buku textbook and banyak buku lain. Sila baca. Sebab tu saya kata don't trust my slide. My slide tu merapu. Tapi ada benda boleh percaya, tak percaya. Saya suruh cari tu benda boleh percaya lah. Graph is correct and important. So that's why kita kena datang kelas, and that's why tak cukup dengan slide. I want to force you to read books. Okay. Alright, let's close the class today. Can we have somebody? Siapa yang tak baca lagi doa? You know who you are. Cepat sebab ada meeting ni. Oh, kata cepat kan. Siapa yang tak baca lagi doa? Ke semua dah baca? Semua dah baca doa? Siapa tak baca doa lagi? Pak A, cepat. Pak A seorang je tak baca lagi.
I don't think so, but whatever. Subhanakallah wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wal 'asri innal insana lafi khusr illa alladhina amanu wa 'amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. اللهم اغفر لنا ذنوبنا ولوالدينا وارحمهما كما ربيانا صغيرا اللهم اكشف عنا من البلاء والوباء والفحشاء والمنكر والطعن والفتن ما لا يكشفه غيرك صلى الله على سيدنا محمد وعلى اله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين.
Alhamdulillah rabbil alamin. Thank you. See you insyaAllah next week. Okay. Go and go and get as much as possible question and learn. Sebelum awak tanya saya tu, you do your homework, Google dulu. Then tak faham, baru you tanya saya. Okay? Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.